This is chapter 1.6, Inequalities, day 2. We are working with nonlinear inequalities. And when we are working with nonlinear inequalities, we are going to be factoring our polynomials, and we are looking for either positive or negative answers to know if we have the solutions or not. So if we think about how we would multiply numbers, because factors are values that are multiplied, if you think about how they would be multiplied to end up with a negative, meaning less than 0, or a positive, being greater than 0, answer. To be positive, you would need an even number of negatives. To be negative, you would need an odd number of negatives. So let's look at this first example. Solve x squared minus 5x plus 6 is less than or equal to 0. We know that 2 times 3 is 6. To get negative 5, we would need negative 2 and negative 3, because negative 2 plus negative 3 is 5. That gives us x minus 2 and x minus 3, less than or equal to 0. So then what we need to do is we want to plot the solutions of this, meaning when is x minus 2 equal to 0? That would be x equals 2. And for x minus 3 equals 0, that would be x equals 3. So we want to plot these on a number line. So we go 0, 2, and 3. Now, we also need to consider whether or not we're going to have solid dots or open dots. Solid dots would be for the inequalities with the line underneath. Open dots would be inequalities without the line. Here, I've got a line under the inequality, so therefore this is going to be a solid dot for both 2 and 3. Now what we need to do is test a value from each section of the number line. So I've got values to the left of 2, I have values between 2 and 3, and I have values to the right of 3. And what I need to do is see what areas will need to be shaded. And since I have a less than or equal to 0 polynomial inequality, we want our outcome to be negative. We need one positive answer, one negative answer, because that's going to give us a negative value. So what we're going to do is choose a couple test points. Over here, if I can use 0, I want to use 0. So I'm going to test 0. I'm also going to test a value in between 2 and 3. Let's say 2.5. And a value to the right of 3, I have 5. Okay? It doesn't matter what number you choose, whatever you want. So when I test these, I am testing them with my factors. So 0 minus 2 times 0 minus 3. And I'm checking to see, is that going to give me less than or equal to 0? Well, that would be negative 2 times negative 3, which is obviously 2 negatives, which is not less than 0. So this is not going to work with my solutions. And I'm going to break this into 3 sections here of work, kind of based on my test points. So let's say 2.5 minus 2 and 2.5 minus 3. 2.5 minus 2 is negative 1/2. 2.5 minus, I'm sorry, 2.5 minus 2 is only positive 1/2. 2.5 minus 3 is negative 1/2. Is that going to be less than or equal to 0? Well, that's a positive value and a negative value. And that's one negative right here, one negative. So that is going to be a negative answer. So yes. Okay, if I think about that for what I did over here, this is a negative times a negative, which is going to be positive. Okay, now let's test our 5. If I go 5 minus 2 and 5 minus 3, that is going to be 3 times 2. 5 minus 2 is 3, and 5 minus 3 is 2. That's a positive times a positive, and I have 0 negatives. So my answer is a positive outcome, and I need a negative. So this is no. So that means when I graph my solution, I have 0, my 2, and my 3. I'm going to shade where I wrote a yes. And I wrote a yes in between the 2 and the 3 because that's where I got a negative answer. So on a graph, I have this as an interval inequality. I'm going to have 2 comma 3 with brackets on both sides because I have solid dots. And as an inequality, I have 2 and 3 with x in between, and x is greater than 2. As you can see, my values shaded here are larger than 2. So the mouth of the inequality needs to open towards x, and that's equal to, so less than or equal to, I'm sorry, x is greater than or equal to 2, and less than or equal to the 3. So in between. So these are my final answers here in represented in 3 different ways. Now let's look at another example. I need to solve 5x squared minus 3, I'm sorry, plus 3x greater than 3x squared plus 2. Think in the notes I had greater than or equal to. So let me write in, make sure this is looking the same as our notes. So that's greater than or equal to. All right, so 5x squared plus 3x greater than or equal to 3x squared plus 2. I need one side to be 0. So I'm going to go ahead and subtract the 3x squared, and I'm going to subtract the 2. So subtract 3x squared and subtract 2. 5x squared minus 3x squared is 2x squared plus the 3x minus 2. And that's going to be greater than or equal to 0 because these cancel out. So now I have to factor 2x squared plus 3x minus 2. So 2 times the negative 2 is negative 4. Factors of 4 that will subtract because that's a negative 4. So factors of 4 that will subtract to get positive 3 are 4 times negative 1. With 2x squared, I only have 2 options for my factors, 2 and 1. So 2x times x. 2 is going to only go into, has only, the only opportunity to go into 4. 2 does not go into negative 1. So 2 times 2 is 4. And so I'm going to go over here and line that up with the 2. And it's got to be positive because I need a positive 4. And for x, I need a negative 1x, so negative 1 right there. So 2x minus 1 and x plus 2. And if you look at negative 1 times positive 2, that's my negative 2 for my constant value there. All right, so I've got 2x minus 1 times x plus 2 greater than or equal to 0. So I've done the factoring. I need to solve for these. I'm going to get 2x minus 1 equals 0. I add 1, 2x equals 1. I will divide by 2, and I get x equals 1/2. Over here, I'm going to have x plus 2 equals 0. I'm going to subtract the 2. I get x equals negative 2. Let's see if I can move this. All right. Now I'm going to plot my solutions on the number line. This is greater than or equal to, so this is going to be solid dots. I have 0, negative 2, positive 1/2. I have a solid dot at 1/2, solid dot at negative 2. And now I have to come up with test points. So my separations are here. Any value to the left of negative 2, let's say negative 3. So I'm going to test negative 3. Any value between negative 2 and 1/2, so I'm going to test the value 0. And any value to the right of 1/2, so I'm going to test the value of 1. So when I test the negative 3, I get 2 times negative 3 minus 1 times x times negative 3 plus 2. And I'm going to test to see if that's greater than or equal to 0. 2 times negative 3 is negative 6. Minus 1 is negative 7. Negative 3 plus 2 is negative 1. That's a negative times a negative, which is a positive answer that is greater than or equal to 0. So yes. When I test 0, that will be 2 times 0 minus 1 times 0 plus 2. We're going to see if that's greater than or equal to 0. 2 times 0 is 0. Minus 1 is negative 1. 0 plus 2 is 2. That's a negative times a positive. I only have one negative there. That's going to be a negative answer that is not greater than or equal to 0. So not the values between negative 2 and positive 1/2 do not work in that inequality. So then let's check the value of 1. So 2 times 1 minus 1 and 1 plus 2. Let's see if that's greater than or equal to 0. 2 minus 1 is 1. 1 plus 2 is 3. And positive times a positive is greater than or equal to 0. So yes. So when we graph this officially on our number line, we have our 0, our negative 2, our 1/2. We have a solid dot, and we want to shade to the left of that. So we're going to draw an arrow to the left. We do not want to shade in between these 2 points, but we do want to shade to the right of the 1/2. So there's our graph. As interval notation, I'm going from negative 2 to negative infinity. So I start with my negative infinity all the way up to negative 2. I have a parenthesis on the negative infinity with a bracket at the 2. Because there's a separation of these two, I have to put U for union. And then I'm starting at 1/2 and continuing on forever to infinity. And I have a bracket at the 1/2, parenthesis at the infinity. And as far as in inequality, I am going to say that x is less than or equal to negative 2, or x is greater than or equal to 1/2. And these are my solutions for that. So that's what you're working on for the second day of chapter 1.6 with the nonlinear inequalities. And that's it.